Good. Looks good.
Yeah, so that'll just be.
Wait a minute, when do we, Gene,
When do you think you're going to see something?
Okay, we want to confirm that the first braking maneuver, the first in a series of 4, went off as planned. The computations that were being done there in front of you real time have shown that the maneuver execution was a fraction of % off according to onboard accelerometers, which is another excellent maneuver. Things will begin picking up here pretty rapidly within the next minute or so. We'll get our first reading from the altimeter, and within a few minutes after that we'll begin getting images extremely close to the surface of Eros, some of the closest that we've ever gotten.
okay, okay, yeah, this is good, okay. Yeah, but it's just noise. No,
We're not there yet. You'll know.
You'll know when we screen, huh?
Joe's gonna yell, "Holy cow!" Really.
Well, we ought to see this stuff first, Joe.
Yeah.
We ought to see this guy.
Yeah.
He should be there about 2 minutes before you
Yep.
see something.
Well, we'll see.
Hey, Bobby, only 3 more to go.
Yeah, just about. Just about.
Yeah. Yeah, Bob. Hey, Bob,
Yeah,
Dave's numbers, are those from the accelerometer?
Yes.
yeah.
We're seeing about 10 times that.
Let us know when you hear something.
10 times that from where?
Yeah, they were looking for about 95 hertz.
Yeah, well, it was 0.3 of a degree off. The pointing was 0.32 degrees.
Okay, so I haven't calculated if it's all pointing.
Right.
That's probably what it is.
What do you guys think?
Assessment of it, let us know.
It's what? Yeah,
Got a main-
I know that, but I mean,
0.08.
I mean, but less than 1% off, right?
Less than 1/10 of a percent.
Okay, okay. As long as it's under 1%, I'm not too worried.
Yeah, it's just that we got such a lousy view angle, the line of sight.
Yeah, sure, yeah, right, okay.
Discussion about what we see here.
But if the
they're actually
accelerometer is off
monitoring
less than
it,
1%. So what we're waiting on right now is the LiDAR data.
So we're still over. We're still.
All right.
The images are showing we're still behind the Terminator, which is really good news because if we were seeing the asteroid at this point, we'd know we were way off.
And what's even better news is that in fact the images are coming down. They were supposed to be coming down, and in a few minutes then we should probably move over to the base side and start seeing our first views of Eros.
That's right.
So let's see, and I guess we're all, at the same time expecting to get some altitude data from the NLR instrument that is being turned on, and we'll start ranging to the surface.
Any data yet? Okay, great.
So data,
it's coming.
I guess the NLR data has been obtained, it's being processed, and we should see our first indication of that in a minute here.
Okay, so I guess we're about halfway through the dark images.
Yeah.
Okay, there it is.
Okay, so
First NLR data is in. Okay, go ahead. Yeah.
Okay, the first point is a little bit high as we expect because we're slewing in from the horizon, so it's not looking straight down. It's looking down and several degrees off. The second measurement is really right on. Maybe a couple of hundred meters low, but that's within the norm. And so we'll just wait to see how this line fills in. Okay, this is the plot that we have for real-time data.
No, not yet.
You will see these dots fill in as time progresses. The solid line is our predicted range measurements from the NLR spacecraft. Should point out that we're not looking straight down when we generated this line. The NLR is looking down but somewhat off to the side, maybe by 20 degrees. So this is an approximation of what the altitude would be, but it's not quite. You can see the different structure in here where the different burns take place. These dots you will see fill in real time, and as you can see it'll take a good 40 minutes for this to fill in. So we'll be monitoring this as time goes along.
Okay, we're anticipating getting an image here in one of these moments. Oh, What's that? No, 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 that's not it. Oh, I was getting excited there. Is it getting more hits?
No more hits.
Oh, there's
Okay.
another one. Oh, look at this.
Okay, third line is coming, and now we're starting right down the line, and it's looking very nice.
Yeah, yeah, perfect. Okay. It's going right down.
That's right. And we actually are getting images, Bob, except we're still
Okay,
on
so
the
there you
dark
have
side.
it. Looks like the altimeter is pointing in the right direction, and we're currently at an altitude of 5.4 kilometers over the surface and tracking the nominal descent profile. That's it.
Cosmic ray hits.
That's from the predicts.
Yeah, so get rid of that.
Oh man, that thing is right on. Look at that. Should have used this in the feedback loop. Right? You had your feedback. Yeah.
Awesome. Okay. Very soon, just a few seconds.
Pictures have been coming back,
Yeah,
but they're blank. They're the dark side of the asteroid stuff.
Oh, I think it's sky. There's a
No, no, we're on right down the dark side, yeah.
dark side.
I think we are, yeah.
Could be, yeah.
No, it's off the limb.
Off the limb? Okay,
Off the limb, she says still.
Okay.
Yeah, okay.
sorry.
Next minute or two.
Next minute or two goes on the limb, okay.
He's got a whole batch more dumped in there.
Well, Mark, we're about 5 kilometers off the surface, as we can see from there, so we don't need this. It doesn't work.
Oh, Eros.
Okay.
Next image.
All right. Yeah, it looks like we're. Yeah. Okay, we got our first image as expected. As expected, Mark, we moved off the sky and we're just drifting into Eros. I think first and second images. The surface, so it's pretty hard. On as fast as possible.
We're scrolling back here.
Yeah, yeah. And we're looking at that first image again. And this is the second image. We're going to wait for the third image to be processed. We should mention that some of the hard work that's being done by people behind the scenes, 2 members of the imaging team, Scott Murchie and Louise Proctor, are responsible for making these pictures available to us in real time. And here we're now seeing things that we haven't seen before. The surface of Eros at a resolution of probably something like 2 feet across. In this particular place you can see a lot of boulders, individual boulders, maybe 10 feet across. It's a very flat surface, and remarkably notice that there are almost no impact craters. If you look very carefully, you can see the ghost remains of what used to be craters that have been filled in a few places. There's one particular mark right here, for example. There's another one over there. Yeah. But it is an amazing surface that has been covered probably by ejecta from other impacts, or perhaps by material moving down slope, because we are near the edge of the Eros Depression.
Okay, so now next image is going to come up, and it's going to be a large boulder field in here.
And here again, in detail, we have never seen before, is a clump of boulders that came out of a cratering event, probably, perhaps on landing, fractured itself into this cluster of boulders that we now see. But again, in the next picture, the remarkable thing that we see here is the real absence of any fresh craters. This surface has been covered with a lot of regolith, and there only remain these ghost rings of a few ancient craters that have been covered up. It's really a very amazing sight, and I think completely justifies us selecting this particular area of the asteroid to look at.
So real briefly here, we're just going to switch over to see if we can get the altitude range up yet. I'm not sure if it's working, but I'm going to give it a try.
Okay, I think from the NLR predicts we're about 5 kilometers or so, or 15,000 feet. And nominally the resolution should be about 80 centimeters, or a little bit better than that. Okay. There we go. We now have the range displayed. The first picture about 6.2 kilometers. And we'll slowly be getting closer.
This is 6 kilometers above?
Yeah, we're going through a sequence of images here that we have processed.
Oh, I see.
And the best one we have so far is closer to 5 kilometers.
Right on.
And Bob, it's quite an amazing scene here because
There's going to be some new ones here in a second.
What range is this?
this is just over 5 kilometers. But what's amazing is that
Look at that
the
stuff.
surface is absolutely devoid of any fresh craters.
Look how angular all the,
Look
Right.
at all
the
those.
boulders are.
That's right. There are all sorts of shapes of boulders, some of them very, very angular, some of them almost slab-like. It looks like, you know, they were
You're saying
excavated.
black monolith, are you?
Not yet, no, not yet. But certainly the camera is working beautifully. The spacecraft is doing what it's supposed to be doing, and we are in for quite a ride here. As we get closer and closer to the surface, we should see things better and better, and probably find out that there are many mysteries about Eros that we still have left to solve.
LiDAR is right on.
Excellent. LiDAR is working, the camera is working.
This is 5.3 kilometers above the surface.
This is 5.3 kilometers above the surface, so the resolution is better than about 2.5 feet or so.
Yeah.
Get some more
Could have
just
done
about
feedback.
sharp.
Yeah, I see that now. I admit it.
And the thing to remember is
Scott and Louise
that...
are all excited to get you some really good boulder right in the middle of it.
Oh, all right. We just heard from our image processors that there are some great images coming up. They see them a little before we see them in the mock here, because they have to do some of the preliminary processing to convert the spacecraft signals into recognizable images. So they get a chance to see them before any of us see them. At this altitude, or across the image, the dimension is about 750 feet. This particular image, the exact altitude has just been determined from NLR, is about 5.54 kilometers, 5.5 kilometers. And as I said, and we have just been told that there are 2 or 3 other images that are being processed. One of them apparently contains a humongous boulder. So there it is. That's quite a boulder up in the upper left, and the dimension on that guy must be about 50 meters or so. Probably not a good place to be when that thing came down. What is remarkable is that, again, the smoothness of the surface. It's very heavily covered by very fine regolith, and interspersed with some of these boulders down to our resolution size. So we can see, we're looking clearly at this, that there are boulders about 1 meter across, right, Mark?
That's right, that's right. And we're getting closer to the landing site. You can see the sun angle starting to get more favorable, so we're seeing longer shadows, which will really help us see the craters better.
That's right.
It's amazing how the surface looks like what we were thinking and hoping. I guess the hoping is the right word. But we were thinking that it's very loose material. In the small craters, you can see them as ghosts, and they're infilled by this regolith.
One of the questions we had, of course, before this was whether some of the craters were eroded by impacts or whether they were being filled in by debris, and it looks like, at least in this area, that filling in by debris is an important process. So. All right.
Is this looking better than anything you've seen?
This is looking much better than anything that we have seen. We have a humongous boulder up here in the upper left.
How big is it?
It's about 50 meters across or so, 150 feet.
You're seeing a lot of
the size of a building, actually.
And this looks very different from what we were seeing in Altitude Flyby, both in
Right.
a couple weeks ago and last October.
That's right. That's the experience we've had. Is that Eros, when we get close up, is a very diversified small asteroid, and different places on it really have their individual characteristics.
Boy, look at these guys
and
that
here,
are partially buried here.
And here we again see this surface with buried boulders and covered up craters, and marked down here it looks like there is the remains of a boulder peeking out through the regolith. One of the things that we're interested in is seeing whether any of these boulders have light scattering properties that are different, that might suggest different compositions, but so far they all look pretty much the same. Possibly because they're all covered by a fine layer of debris.
Yeah, and we're just about 5 kilometers above the surface right now.
Okay, and again, about 5 kilometers. The official resolution is just less than a meter, so it's about 3 feet, or more like 2.5 feet. And we're now looking pretty well straight down on the surface, so we're seeing things fairly well. And what is remarkable is the total absence of any fresh, large craters. This has been completely painted over by regolith. And again, if one looks very carefully, there are places where there are hints of the remains of ancient crater rims, right, Mark?
Yeah, and we're seeing boulders. As we get closer and closer, they keep popping up at all scales. So it's just as we expected, that it's very bouldery at all scales. And if we could get down at a human scale, it would be very loose regolith of soil, like the astronauts made those boot prints in the surface.
Right. The other thing we should, of course, say is that now we're getting close to about 4.5 kilometers. We're getting closer and closer to the surface. And the surface still looks remarkably smooth, so we have to say that our mission director, Bob Farquhar, picked an unusually smooth landing site. I don't know what information Bob had to pick it, but he
didn't have any. It picked its own, you know. But this is good.
But so far, this looks about like the best place to land on Eros. Compared to some of the other areas we've seen before at lower resolution, which were, full of steep cliffs and boulders and very rugged topography.
The other good news here is that we're coming in a little bit high, which means then that'll probably last a little bit longer. You'll get some more pictures.
Right. Apparently, the NLR data indicate now that we're coming in just a little bit higher than predicted, which means the descent will last longer.
Oh, that's great. More pictures.
Which, for us people who love images, means more images and a better show.
We're about 4.
Oh, it's still good. It's still right on. Yeah. This is good. And
4.3 kilometers.
Yeah, we're getting on to about 4 kilometers, so
extend it a little
now
bit.
we're getting to the
that'll
point
guarantee
where,
that one goes up.
we're about 650 feet across.
Okay, we have an update. The second of the series of 4 braking maneuvers appears to have gone very successfully. Dave, do we have an idea of the percent error?
Yes, it's a quarter of a percent under burn, and the angle is 0.9 degrees error in pointing.
Okay, so it looks like a nominal burn cutoff, and we'll be performing the third in the series of maneuvers here in just a few minutes. So we're two for two here so far.
Hey, Bobby. Hey, Bobby? Yeah, it looks like we're a little bit above the glide path, as it were, right?
Yeah, right. Yeah, we're confirming that.
So that means then that we're probably going to go a little longer, right?
Oh, sure.
Yeah, right now Eric's showing us something like 3.3 kilometers from the landing site.
Okay.
At a radius of 9.1 kilometers from the center.
9.1. The nominal was 6.4.
Does this mean that we probably won't get any occultation afterwards?
Well, we can't be sure of that yet.
Okay.
The higher is better.
Yeah, higher is better.
Details of these boulders that have impacted the surface.
And also, as a first impression, it seems as we get lower in the we see smaller and smaller boulders, that a larger percentage of them are very angular.
That's true. That's
A
true.
lot of the big boulders are broken up and
That's true.
and degraded.
And the smaller boulders are very angular. In this particular image, one's beginning to see some very angular-looking things poking out of the regolith.
Yeah, you should see them spot right there.
That's right. But it's really an amazing surface because again, there just are no fresh craters here. This has been covered geologically recently by ejecta or debris moving down slope.
Here's another buried one just poking through in the bottom right-hand
Right,
corner of the frame.
right. And here is another angular boulder coming out. Sure.
Coming down. Oh, we're right back
So
on.
we're anxiously awaiting for next batch of images because we're now getting down to about 3-kilometer altitude. Now here's something quite
Yeah,
amazing.
here's one with the aprons around it, and this is, I guess this is more ponded deposits. Very
Right,
close resolution.
some very flat areas. And one of the things we noticed in a few of the previous images at coarser resolution is that some of the boulders appear to be disintegrating in space, producing an apron of debris around them. And the puzzle, of course, on this airless body is what may actually be causing this disintegration. This altitude here, this image was taken about 3.6 kilometers from the surface. And things are getting better and better, so we just can't wait to get closer and closer. Everything is working fine.
The resolution is about a half a meter.
The resolution is about a half a meter, about a, foot and a half or so. And
0.5 kilometers over the surface. This is closer than the craft has been to the surface at any point in the mission.
the camera is working fine. The viewing conditions are getting better and better as we get closer to the surface, and we're looking more vertically onto the surface. It is still a remarkably flat area, smooth area.
Yeah, pretty soon now we should start seeing rapid changes in the incidence angle, so we'll start seeing a lot more shadows,
right,
and maybe see better the subdued craters that we can just barely see at this point.
As the lighting improves, we can
as
take
we
those.
go over that facet on the asteroid and get closer to the landing site.
Right.
Right about here.
That's what I'm getting.
Okay, how many you got? Any new ones? Nope. Yeah, well, it's one off from the latest one. 5618.
That's going to be about, about 6
Yeah, it looks like our image processors are taking a break here, but I'm sure they're working hard.
5 to 7 miles an hour.
Oh, look at this. I guess.
That's 6 miles per hour, right?
We like to keep our uncertainties on everything.
Almost buried, yeah.
Oh, it's coming in. Look at that thing.
These are, that one's pretty deeply buried.
Yeah.
I don't think we've ever seen any.
This is the only place where this thing's plotted up? I think this is the only place,
I
right?
think what's
Hey,
really
Dave.
exciting is that we've
But this is
Tell
good. Shows
Dean
up
Hyman
good.
we think he's cooking the day.
Sure.
so now that we can't really know.
And I think what this indicates is
meters
that
at the most.
as you get to
Okay, okay.
Now, Bobby thinks you're faking the data.
We're not faking.
That's amazing. It's
We can
amazing.
hear everything he's saying, too.
That's all right. That's okay.
If we faked it, we'd do a better
Well,
job.
this is one of the highlights of our lives here, right? Because,
Same here.
we've been wondering what asteroids look like, and now we're seeing it, and we're seeing it better every minute, and we've never seen asteroids in this kind of resolution before. I think we're totally amazed by the fresh craters that are completely removed from the surface. Okay, and I can't wait what the next few minutes will reveal.
Gravity
Yes.
model.
Yeah, absolutely.
He's right here. Listen.
We've seen 36 in there. Last one is 415618.
still trying to find out.
415.
So, Gene, we're about 2 kilometers almost.
We're slant range is about a little over 2.
2. Hey, Bob, this is great. Hey, these are the
No, I know.
best images ever.
Hang on. Nope.
Are you seeing anything new, though?
We're seeing lots of things new. We are absolutely amazed by the absence of small, fresh craters. We are
What are
also,
the size of some of the smallest rocks on there?
well, the scale up here, we're now about 250 meters, and so so that rock probably is about 10 meters across. We're seeing detail to about half a meter now.
Okay. Oh, we want to do better than that.
Well, we're going to do better than
They just
that,
showed up right
but
now.
this is much better than we've ever done. So,
Okay.
Okay, we got some more images.
so more images are coming down, and
We've seen this one. We'll just
Yeah.
scroll through the last couple.
Right. The other thing I find interesting, Mark, is that there are a few of these fairly angular
getting
things
data
there.
points. Looks pretty good.
It's barely poking through. Like there's another one, of course, that's not angular. It's barely poking through.
I think we're gonna.
Oh, that's interesting.
I think it's.
Oh
Yeah,
yeah,
that's
look at
a,
that. That looks like a
okay.
fracture.
Hey Bob, we have a big boulder that's fractured. Now we can see detail at tens of centimeters.
Yes.
There's a boulder that
Look
came
at that.
down. You can see the cracks. You see it
Yeah.
completely fractured
Oh, yeah.
on impact. So,
Oh, that's
Now
an
let me
actual
refresh for
crack.
you.
That's
What's the
an
width
actual-
of that crack, would you say?
well, that's got to be a few pixels. That's probably about a meter, I would think. It's actually probably big enough that you could squeeze in because you're such a thin person, but it's a pretty narrow crack.
Maybe you could do it.
Yeah, some kind of boundary. Right. Okay, we're apparently down to 3.4 kilometers, and Mark, we can still see that famous boulder here, which is like a jigsaw puzzle put together here. I can almost see
Why is
1,
it
2,
black
3,
and white?
4,
Oh,
5,
that's
6
shadow.
shadow. It's a boulder, maybe about 10 meters across, that broke off into about 6 different pieces, probably on landing, which eventually will give us some idea of what the strength of these rocks is.
Well, as you pointed out numerous times, all the ghost craters in here, I guess that mystery is solved, is why there aren't small craters on the asteroid, because they are there, they're just covered up.
It's just covered up, that's right. I guess what's happened fairly recently geologically is that a lot of material came into this area from somewhere else. And I guess the puzzle for us will be to try to decide whether it came in as ejecta or... Well, I think we actually, no,
This is the next one.
but to me, you can see the bottom of it over here,
Yeah.
and it looks like a ghost crater again. It looks to me like a large crater, and there are some boulders on the rim of it.
So we're at about 3.3 kilometers above the surface.
3.3 kilometers, so we have about 180 meters from edge to edge here, and
Pretty good size.
our resolution is probably like a half a meter now.
Oh, yeah. Oh, I.
So, but it's remarkable that there is preserved probably something like an 80-meter-old crater, which has been quite filled in.
We got a lot of data now. Let's see 10 more images.
Yeah, we've just been told, Mark, right, that we're getting a lot of images. They're coming in furiously now. That's quite amazing here. Now we see a. To me, I would bet that's an old crater.
Yeah, it'll only look like 2-minute maneuver to you, but the maneuver goes for 7 minutes altogether. The steep component is only 2 minutes.
You know how big that offline of sight component is?
This image is about 3.2 kilometers from the surface of Eros.
yeah,
So we're continuing our slow descent to the surface and looking at the images that are coming in. The surface really hasn't changed very much. We now, Mark, you can see the ghost craters.
Okay, I'd like to confirm that the third in a series of braking maneuvers has begun only moments ago. This is a significant transition point because this is the final portion of the onboard sequence. It shows that we did make that transition successfully. This maneuver is about 7 minutes long, and we are now about 3 minutes into the maneuver. We're also down to 1.25 kilometers off the surface. Everything is going according to plan, and as you can see from the NLR plot, the altitude is following the nominal glide path coming down. So we're right on the money.
Yes, they do. Yes. Yeah, so I guess the C component should be over with, the one you
We're
see
just
now.
below 3 kilometers now, and
Yeah,
we're
the
beginning
Doppler
to see
should
something.
stop
It looks like a
moving pretty
tremendously
much.
huge boulder on the side there.
Yeah, we haven't seen much of anything line of sight.
No.
We just started right
Or
now.
well, that's one of the problems with
Must have been what, about
doing this.
16, 15 meters?
Fortunately, folks, we're not going to see that one again because we're heading somewhere else. But the character of the surface from the very beginning has not changed. We just are seeing it at better and better resolution. But
No, what's this one? This one, you squeezed it down, huh?
Smooth deposits in these old relic craters.
now we're below 3 kilometers, and we're now picking boulders up that are just a few feet across. And as Mark pointed out, there is a boundary here, clearly associated with a slope. and some more of the smooth material mark that we've seen before that's filling the low-lying areas. Again, another indication of that over here in that depression. And Mark, look at this, some more boulders that have been probably broken apart, and they're concentrated on the rim of an old crater, it looks like.
We're already at the 49th image.
Yeah. Yeah, we've been getting images.
Okay, the
Apparently
images
the
that you're
count right
seeing,
now
you
is
need to
about
keep in mind that there is a couple of minute delay between the time that that image is taken and processed and the altitude that we're at right now. The true altitude right now is 1 kilometer. The images that you're seeing are probably approximately 2 kilometers. So even after the altimeter indicates 0 altitude, we will still have some images coming in.
Yeah, now we actually, this is probably one of the first sort of craters that we have seen. So there are a few craters here, but
And we're at about 2.45
2.45 kilometers. So we're only about 120 meters across this image, about 300. So that's about the size of, we're now sort of the size of a football field with the end zones.
Right.
And
so this is a suburban house right here.
that's a suburban house, right? And that actually is a fairly reasonably preserved crater for this part of Eros.
That's probably the best one we've seen
For any other planet to be highly degraded. And here's another one. See?
Beautiful. It's got one of those ponds in the bottom.
Yeah, now we see a fairly typical area of Emeralds here, but now the remains again of an old crater with an extremely flat floor. And that, Mark, I guess is a big puzzle as to how those floors get so flat.
And one of the ideas, some of the ideas we've been bouncing around is that when the asteroid gets hit by an impact somewhere else, and there's a lot of shaking, a seismic shaking, analogous to an earthquake on the Earth, and as you shake the surface, the very fine material can move around and ends up in the bottom of topographic depressions.
Right.
We're not sure at this point in time, but hopefully we'll be able to get this figured out by the end of the day. What do you think?
Oh, there's always a chance, but you know there are even more bizarre theories.
Oh, look at this beautiful boulder.
There are some theories that suggest that on an object like this, which has no atmosphere, the fine dust can actually become charged and gets lifted off the surface a little bit and then can drift under gravity into low areas. That's quite an outlandish possibility, but you know at this point we have to consider everything. Well, now we're
2.15
kilometers, so we're really about the size of a football field. So this is about a 15-yard boulder that we're looking at. And the character of the surface basically remains unchanged. It's a lot of craters have been buried with ejecta. The fine-grained ejecta are responsible for a smooth appearance of most of this area.
Okay, so the MM4 is happening just about right now.
And at this point, the last of the burns, I guess, is happening to slow us down.
Is there one more after this? Yeah,
I'm sorry.
This is
okay. Next to the last burn, and one more after this.
It's starting to look a little bit rougher, and that may be just because its incidence angle is getting lower on the horizon. I'm not really quite sure.
That could be, but
like
that's a good point. The craters are also getting a little bit more distinct, the ancient craters. So
yeah, perhaps we're moving into Eros from the.
See, actually, I think in this particular view now we see a lot of boulders, okay, and I don't think it was just a...
No, now it's definite.
I think we're in a transition region now where we're going to... Yeah, we're
gone across that boundary from the smoother unit into the rougher.
Well, Bob, maybe you didn't do as well because we're getting, as we get close to the surface, it's getting rougher.
Yeah, that's all right.
So...
They'll find a soft spot.
Okay, we'll find a soft spot.
Okay, fantastic. We're going to recycle here, Joe.
We're going to recycle, but we have images down to about 2 kilometers now, and we continue to see some amazing things.
Well, we're getting it.
So everything's just working beautifully. It's fantastic.
Again, I guess we should thank Scott Murchie and Louise Proctor, who are...
Yes, they're madly, and I can hear them shouting in the background every time something
we're going under there now.
It's coming under. All the processing for us.
And I think Ben's in the back room there.
Oh, that's right.
Put these into strip mosaics, so that pretty soon we can show how they connect together.
Exactly, and we have some other people working very hard to make mosaics.
You got some more coming in right now?
So everything's working not only...
I don't know if I should say that out loud or not. I think it looks like
the angle is 1.4 degrees off, though. We're getting bigger angle errors now. 1.38 degrees off the angle. Okay, so that was minus 9 millimeters, 3 millimeters per second.
Past the magic
Point,
kilometers.
2 minutes.
Okay, I'll do it. We do have
2
15
minutes.
up now.
Quarter, 0.23%.
Hewitt, they do have 15 up now, they said.
20, 30 centimeters. A foot or so.
The background morphology is still very similar with the
Well, but you
subdued
got-
filled-in craters, but now we've got many more boulders perched on the surface.
That's right. This area really got clobbered with a lot of ejecta. We're now have no trouble seeing things that are about
I
a
can
foot
hear
across.
Mike in the background saying regolith, regolith, regolith.
Yes, I think if anybody had any doubt that there was regolith on this object, I think this descent sequence should put that to rest.
What was that, Scott?
Mark, you might notice that the lighting is getting better now. It's much easier to see the boulders, and we're beginning to see that, at least in this area, even on a fine scale, the surface is kind of textured, indicating that there are pits and little hummocks on scales of only a few inches on the surface, casting shadows.
You know what, I also think that previous we'd commented that it looked like the boulders were much more sharp and angular. Now it looks like they're going back to being a little bit more rounded.
Absolutely, I
integrated.
agree that we maybe are encountering ejecta from a different cratering event, which kicked up slightly different material.
Yes, ooh, wow.
But the boulders here are definitely rounded, this one in particular, whereas a few minutes ago we were looking at things which looked like angular slabs of material.
Yeah.
Okay, we're coming in about
Okay, we're gonna
50
do a
meters
refresh
per
on
second, or 50 meters.
Okay, I think we're going to refresh our images and continue this odyssey to the surface. The pictures are absolutely fantastic. The camera is behaving itself. The spacecraft is doing exactly what it should be doing, and all the people on the ground are doing their work. So it is one of the greatest experiences to be able to sit here and basically accompany the spacecraft on its descent to the surface.
Okay, we got this new batch showing up now. So we're about 1.25 kilometers above the surface right now.
So that's not very far, right? About 4,000 feet. Oh, at about 1 kilometer, well, about 70 meters of 1.2 kilometers, 60 meters.
And 56 seconds after the start, so that would be at, okay.
Okay, I
So-
saw it's still in lock at 15.
Yeah,
We still locked at 15?
Yeah, we still got lock.
59:44, the Doppler, your burn should be, the Z component should be over.
We're showing something like 440 meters to go to the landing site, plus or minus 100 meters.
Plus or minus 100, huh? Okay.
Yeah, the laser shows 330.
Okay.
It ends any time now.
All right. Got locked. We still locked at 15.
Okay, now we should get ready to see if there's some dropout, right?
500 meters. So I don't know if I trust it.
Okay,
Too soon, you think?
we have begun our final braking maneuver, and we're currently only a couple hundred meters above the surface. And
We're showing 340 meters to the landing site.
yep, just a few hundred meters to go, and we're on track for a nominal landing in approximately 4 minutes.
Never know.
Still in lock. Still track.
Oh, wow.
Oh, yes, it's getting
Oh,
better.
this is beautiful. Oh, look, this is where
108
we got
meters.
it.
Oh, boy.
Now, of course, we're at a resolution now where we can actually see details on individual boulders, and here we go.
Yeah, I think we might hit during
There's a
this,
little bit of
burn.
drop data here
Right,
that
that's
occurs
right.
sometimes, but the detail on that boulder, about
Yeah,
1
yeah,
kilometer above the surface,
yeah. Gene
we're
Heiler
seeing
confirmed.
detail sort of 10, 20 centimeters across, so it's, 10 inches or so.
Right.
So
This is a meteorite that we're seeing on the surface.
that's right. And you can actually see that there are some angular boulders and some rounded boulders, and we're
Oh, this
and-
is just unbelievable.
absolutely unbelievable. We're probably seeing detail now at the scale of a few inches, and
10 centimeters or something.
10 centimeters or so. We're about 1 kilometer from the surface.
Yeah, exactly.
I guess we're exactly about 1 kilometer from the surface right now. So we're looking, the width of the frame is about
I guess so.
50 meters, 150 feet or so.
Okay,
And,
the next frame, it's going to be
what's
gone.
interesting, Mark, as you just pointed out, there's a large, fairly large smooth area, about just below 1 kilometer now. And we're seeing detail, a few centimeters, you can see details on the rocks, and there's a smooth area coming in, Bob, and
Out
that's
of
where you're
lock
heading,
on
so it
station
looks
15.
good. Oh, yes, but the remarkable thing again is that all the craters
Okay,
are
that's
very
it.
subdued. So there's been a,
No, 14's
a lot
back
of
in lock, you
implication
said,
of
though.
ejecta from somewhere else in fairly recent times.
Must have bounced up. Okay. Might have bounced.
About this much.
Yeah,
Okay,
Well,
yeah, I
wait a
said
minute,
14
wait a minute.
is back in
Wait a
solid.
minute. I want to confirm first. Still in lock? Is break 4 over?
No, we haven't got an indication. We're not getting a frame update, though, either.
Hey, Bobby? Yeah. Did break 4 finish, or what are you seeing?
Well, we see both 14 and 15 out of lock at this point.
Okay, are you seeing anything else?
No, they don't see anything. They don't have a signal.
Well, let's see what the story is.
63, right? Did I copy?
Are you in or out
Okay,
of
we
lock?
still 63 still shows the lock.
Still got lock. Keep going.
MCD is out of lock, so we're not the resolution on the thing. The carrier is still locked. The data is out of lock.
The carrier's still locked.
Simply going in and out, so the MCD's not staying locked.
Are we on the surface?
There's delays in the system. I can't say for sure. The final reading was 0.017 kilometers, so that's 17 meters. 18 meters.
But we haven't dropped. We haven't lost the signal yet.
We must have contacted us because we did get the signal interrupted.
Okay.
But it's probably trying to maintain attitude.
Okay.
You know, so maybe we'll get it back here.
Yeah, good. Okay.
6-3's got it up. You're gonna get some good pictures. Lock at minus 155.
Still have lock.
Minus 153. We're good.
We're not getting any data.
That's all right. It's still in lock. It's still locked up. Yeah. Evidently, it looks to me like it might have touched down and come back up again, but we'll see. This is delayed.
I'll tell you what, Bambi's a whole lot
Other
better.
craters throwing out stuff.
Oh,
you know,
gee.
so you're talking
Last
about
one
timescales
is.
of
It says it's on.
millions of years. Okay, but
Last one was 17 meters, but
But you're
we're
correct. We
still
don't
in
know
lock
the precise
somehow,
timescale.
so
Tom.
let's see what the story is.
Okay. So how
We don't know yet. I gotta find out. What do we got?
the NLR is
No telemetry, but we have
laser
lock.
altimeter is taking data.
Have lock. Is it moving at all?
The signal is going in, it's okay.
Do you think it's on the surface? That's the thing I want to know.
Without telemetry, I couldn't tell you. Not for a while. When do we switch to the fan beam?
15 minutes after.
13 minutes from now. 13 and a half minutes, we switch to the telemetry. We switch to the fan beam.
Okay.
You want to tighten it up?
Okay, so let's see if we're getting another.
So what's up with 14? Why isn't the MCD gonna? We got to get those symbols straight.
How's 14 doing?
14 doesn't have the receivers in lock. 15 does.
63 does.
Yeah, 63 does. I told you guys that a few minutes ago.
I know.
It's still there?
Broken apart.
14
Still there?
does not.
Now, we're supposed to, we're beyond 6310 to track. How long can they support?
They can go a little longer. You want me to make a statement here?
He's ready?
Yeah, I guess I can start saying something.
How far are we now from Earth?
2.11 astronomical units.
200 million miles.
A long way.
About 200 million miles, right?
Yeah. He's still getting images. They're going to come in. They're lagging the what's actually happening.
Bob, let's make your announcement, please. Stand by.
Okay. Yeah. Sure. Okay.
She's going to say something.
I'm happy to report that the Near spacecraft has touched down on the surface of Eros We are still getting some signals, so evidently it's still transmitting from the surface itself. But we have gotten, all the pictures are still coming in. This is the first time that any spacecraft has landed on a small body.
Congratulations.
That's good.
Thank you. Bob,
That's good.
congratulations.
That's good.
Wonderful.
That's great. There's my favorite senator.
Well, thank you.
I'm going to stand here. This is the place.
Hey, Bob.
In here. Yeah.
14 just reacquired, sure.
Reacquired. Okay. All right.
Negative 141. That's great. That's great. That's like total nominal Earth point. What's the status there, Carl? Neg 141 on 14, which is nominal Earth point down.
Okay, in 18 April, we get the baby.
I got Kate on the phone. Who? Kate on the phone. She said that on the big dish on 14 that they reacquired at 10 dB down, but they're locked right now, and they can still see it on the open loop receiver.
Is it on the high gain, medium gain, what?
It's on the high gain still.
It's on the high gain.
Yeah, but it's the signal level is lower than it was.
Means that you're off on the side there.
Probably, possibly, yeah.
Yeah, it's a NASA animation, right? You're right on.
Is it? Yeah.
Hold that
Stay
signal.
on the line, okay, Kate?
Hold the signal.
There's a lot of confusion.
Yeah, that's okay.
It was a year ago, almost to the day, when this group of people gathered in this room to find out if Near Shoemaker was going to orbit around Eros. And it was a wonderful event when it did. We wound up getting a wealth of scientific information that we haven't begun to understand yet. And the pictures that we've been looking at for the last hour or so have just been absolutely spectacular. So there's obviously a lot of work remaining. Wanted to recognize Congressman Bartlett, Senator Sarbanes, Dan Golden, Administrator of NASA, and Ed Weiler from NASA headquarters to share in the wonderful achievement of this entire team. I'm going to turn the microphone over to Tom Kremegis, who has led this group to this amazing achievement.
Thank you very much, Rich. Before I say anything about the NEAR team, I want to make sure that we thank outside organizations who helped us a lot, and that includes the help in navigation that we got from the Jet Propulsion Laboratory, the Aerojet company that built the rocket engine that worked so wonderfully all this time, and of course all the scientists from many institutions across the country who did a wonderful job in picking the right place and did all what was necessary to make sure that we land in the right place, that the spacecraft apparently, even though it was a controlled descent, and it has apparently touched the surface, and maybe, as Bob said, we are still receiving data. What can I say about the NEAR team here at the laboratory? They underpromised and overachieved.
Exactly what they did.
I agree. They said that they would do the job quickly, and they did it in 26 months, and they didn't spend nearly as much money as had been budgeted. And so they have done a super job in setting a new standard for planetary exploration, and I don't know how I can thank them enough. Now, of course, perhaps I should, before I ask our congressman and senator, I would like to give a chance to the NASA administrator who coined the better, faster, cheaper motto, and it became part of the United States vocabulary everywhere. And he kept reminding us that better comes first. The NASA administrator, the Honorable Dan Golding.
Thank you, Tom. Oh, come over here. I think the people here at the Applied Physics Lab and everyone who worked on the team, the NASA people, the Jet Propulsion Lab people, demonstrated that they had the courage of their own convictions to define a difficult mission, to execute that mission in 26 months from turn on to launch. And by the way, this was the first faster, better, cheaper mission to go. We had problems in orbit, and I remember talking to Tom. I said, don't worry about the problems, do what's right. It's a success as it is, but you did unbelievable things. So I'm just overwhelmed with the courage and the talent that it took to get to this point. Congratulations all.
Thank you very much. Now let me introduce our Senator Sarbanes of Maryland, a member of the Senate Science Committee, who sees to it that there is sufficient funding flowing to the space program to make all of this possible.
I knew we would get to that part of it. First of all, I want to really commend all who have been involved. APL has done just a terrific job. They did it in record time, under budget. The spacecraft collected 10 times the information it was projected to collect in the course of the one-year orbit around Eros. They've ended it on almost on Valentine's Day, which also fits in, of course, with a name. I want to congratulate Dan Golden and the NASA people who entered into this partnership with APL and the other institutions around the country that worked with them in order to make this possible. This is a terrific, the achievement actually has happened over the course of the past year. This was actually the end of the spacecraft, and by making this decision to come down on the asteroid, they were able to gain even additional information, which will be of great use to us in the future. So congratulations all around.
Thank you very much. And now let me ask Congressman Roscoe Bartlett of this area of Maryland, a member of the House Science Committee, and a former member of the Space Department of this institution, who also is very keen to see that the space program goes well. Congressman Bartlett.
Thank you very much. This is kind of an emotional experience for me for two reasons. One, I am a scientist, at least was in a former life, so I can understand how exciting this is to those who are responsible for it, and congratulations, you did a great job. And the second reason I'm kind of emotional is that this is my alma mater. I worked here in the Space Development Division for 5 years, and out in the hall you'll see my name as one of the principal scientists here. And I was kind of instrumental in introducing APL, because I just knew of the great capabilities here, introducing APL to NASA, and so I'm really delighted that this kind of first venture has been such a great success. Congratulations to all of you, and congratulations NASA for recognizing a good thing when you see it and coming to APL.
Thank you all very much. We have a short activity over in a reception at the Kosyakov Center, so please let's proceed there, and where the press is, and you may wish to talk to them about the tremendous success of this day.
We already have souvenirs, they're already postmarked. Hey, look at that. Oh, that's the last picture.
See, it takes us 30 seconds. 30 seconds to get there. Yeah. You got it.
Good.
Yeah, call a National Enquirer.
I wouldn't forget you. I know you save these things. Okay, here, yeah. I can get some more.
Congratulations. Peter Marbutis, the Senator, Chief of Staff. Nice. You did just a terrific job.
He actually votes for us even though he's a Republican.
I don't know. He called the Senator his favorite senator. I heard him.
Well, this
always happens. We got
Mark speaking over Mr. Golden in the pit.
Okay. Mr. Golden's going over to the pit. Mark's going to give you an update while that happens. Okay. We need an update at the spacecraft.
Okay. We still got carrier, guys?
We don't have carrier lock, but she can still see it on the open.
Okay, we still see a signal.
The open loop receiver. We're waiting for a fan beam in a minute and a half or so.
Okay.
You're the only one working and everyone's...
Yeah, they're all.
Okay.
It happens all the time.
Just want to confirm that
This
the
our mission
Near
operation?
spacecraft has come in contact with the surface, and we are still seeing a signal from the surface. We're in the process of reconfiguring the RF system. In about a minute and a half, we'll know whether or not we can get some telemetry back from the surface.
We're going to try to get magnetometer data back. I mean, just in case we got lucky, we wanted to.
You
play.
noticed after you hit, something went wrong, so you didn't get any more signal transmitting.
Yeah, we didn't get, but we got carrier back. And so that's how we knew that we were down. But these guys can tell you better than me. This is Mission Operations Manager Bob Nelson.
Thank you. Congratulations.
Dina, Rick, he plans all the stuff.
He
There's
helped
Nick.
us.
Bob Bakulik is the RF guy. He's very important. This guy does all the work. We take all the credit.
They all stand on your shoulders? Oh, yeah. I'll work together.
Huh?
One work.
Signal's getting bigger. Signal's getting bigger. He says signal's getting bigger.
Oh, is it?
Oh, thanks. That's good. That's good.
Centimeter resolution at the end.
Yeah. This is good. This is good.
Okay. Well, we're going to know something here in 30 seconds or so.
Oh, thank you very much. Thank you.
Signal, right?
Yeah. Oh, here, I get.
Just imagine. That was my greatest fear, that we would get a signal.
If you hear everybody tell you, let's take over, you never know.
Well, now, I got to tell you I got to tell you that we got another burn in there to happen in a couple of days, but we can take it out. But that's just was to move it so that we could get a signal back. We never thought we'd keep getting it. It's amazing.
Still getting a signal now?
Yeah, it's stronger.
You're still getting carrier?
No, we're going to start. Well, it's a stronger signal. They might get telemetry. I don't know yet.
But what kind of support? What kind of?
Okay, controllers here are still anxiously awaiting some telemetry coming back from the spacecraft. We are about 2 minutes out from getting the DSN reconfigured to receive low bitrate telemetry. We're looking for 40-bit telemetry, which is 40 bits per second. The last frame of telemetry we received was approximately 17 meters off the surface.
I think I'll let you go. Yeah, the last image was 120 meters off the surface.
Is that what it was?
It was 6 meters across. Still in focus.
What are they doing?
So the patient still has a pulse, but his brain is not working?
Why it wasn't working, it wouldn't reconfigure. The brain is still a signal now.
At least we weren't occulted. That's great.
That's true, too.
Yeah.
Is there any possibility that it's still in a, by now it's landed already? I mean, it bounced up because we did it during the maneuver. It landed during the maneuver.
That's right. That's right.
So
Yeah,
it
well,
must have
61% of the maneuver in by the time it hit.
But the viewing geometry is going to be improving, right, over the next... When was the planned, when was the occultation zone over?
It was 38 minutes from the time of landing.
So we're
actually
20 minutes.
Worse and then better. So but
Okay.
It almost certainly bounced up a ways. Maybe
probably did.
100, 200 meters.
Yeah.
It's 200356 was supposed to have been the window.
23056?
Surface occultation.
What did you say? 23 what?
200356 was when we were supposed to have.
Yeah, right. That was the nominal landing time.
I think they should have one receiver two way, one receiver one way. 14, 15.
They are, they're going to right now.
But it could be in one way. We get one frame back.
It was amazing. We were a little bit away was how flat and smooth it looked. Like, oh, this looks awesome. As we got closer, it was like, where did that rock come from?
I need you right now.
Well,
What time and what time?
okay. Mark. Thank you, Tony. How far out? Okay. How far out was that last?
20 or 130.
Okay. Was that the one we were just looking at? Was about?
But the birds really did exactly what you so wanted. Yeah, good. Excellent.
That was the final picture.
Yeah. So
Okay.
you can't argue with that
I
one.
wonder if we can get them to put that back up.
In anybody's record.
That's one we ought to show everybody, right? Maybe we can get them to get them. Right. He's got that picture there. Mark really ought to talk to. Mark Robinson? Yeah, he should talk to him. Is that's you know what they say? I mean, that's the last picture.
The picture that's up right now.
That's why it's grainy on the bottom. That's why they lost the transmission.
What happened?
What's that?
130 meters. This is 6 meters across the field of view. This is the very last image. Garbage at the bottom is because the spacecraft impacted while it was sending the image back, and we lost that last 25% of the image.
Why don't you chalk it up? We're gonna give you a cue. Say the image you're looking at
Right now?
What's this last picture?
Yeah, right here. They want to put it on the screen, apparently. Yeah, this is 6 meters. No, I mean on that screen. It's 6 meters across is the field of view. Isn't that unbelievable?
Why didn't we get it down to 3 or 4 meters?
Well, because you didn't do it very good. And see, this is where we
look
lost.
Look at the big boulder we just missed.
Yes. Yeah, but look down here. Look at that picture up real close. That sort of rivulet-looking thing. Explain that.
I think we dug in there. What do you think?
Okay.
Pardon me. I'm going to see what's happening.
Okay. Well, we've got. This is the very last image that was acquired before the spacecraft impacted to the surface. And the spacecraft, when the image was acquired, was about 120 meters above the surface. And what you're looking at right here on the surface, the width of that the total width is only about 6 meters across. So that's 20 feet across. You're looking on the surface of Eros. And we got about 300 meters closer than we thought we were going to get the last image. Incredible success. And you see right in the top here is this boulder that's got either cracks or some sort of structure in it. And here's one of the ponded deposits that we were really hoping to see at high resolution. And boy, did we get lucky. The highest resolution image is right on it. And down here we see in the bottom, the mess that you see here is missing data because the spacecraft impacted to the surface of Eros while it was actually sending back this image. So that we lost that part of the image due to the impact. But what we were just beginning to see is some sort of very strange rivulets that kind of baffling right now, but hopefully that will give us some clue to understand these enigmatic smooth deposits that we've seen all over the asteroid now.
Surface, that's pretty clear. That's pretty clear.
Bobby, are you calling?
He's got greedy guys, you know.
Picky. Congratulations.
Bobby, are you calling for Dave?
Thank you.
Yes, Jim.
Oh, wait a minute. She sees the signal again.
Wait.
Really?
Yeah, don't leave. Don't leave. Hey.
No, seriously?
You're kidding?
No, I'm not kidding.
Yeah,
They got the signal back?
They got the signal back.
Okay, thank you.
Pick back on the open loop.
Okay, on the open loop. Okay.
Are you trying to run away?
They have locked. I don't know about telemetry.
Still locked.
Is it two-way? Yeah. So we still have the uplink.
Okay. All right. They got it again. Still there.
I believe so.
Stand by.
Take them. Okay, controllers right now are trying to reacquire the spacecraft with a two-way communications link. Right now we have a weak signal coming back from the spacecraft. This is still on the order of 25 minutes after the first contact with the surface. So this indicates that the spacecraft's guidance and control system, power systems, and communication systems did survive the impact. What we're trying to do right now is get a better signal from the spacecraft. Currently, we're coming out of a period where we expected the Earth to be very low on the horizon of the landing site, and we expect it to gradually climb over the course of the next at least the next hour or so. So the fact that the spacecraft survived and that we do see some sort of signal coming back is certainly reason for some optimism to hope that we might be able to get some data back from the spacecraft. But as you've heard here, the landing was a success. We have some very close-up images taken just before the impact, and the spacecraft does seem to have settled down at a soft enough velocity to have survived the touchdown. So this is going to play out probably for some time here this afternoon as we continue to track the signal and see if we can get some data back from the satellite.
Bobby West just told me what the update was, then he left.
Oh, okay.
2 minutes early and 1.5
Okay.
to 1.8 meters per second.
Okay, good.
Hey, Bob.
Yeah.
Looks like we impacted about 2 minutes early. I was wondering, do you know if we got any telemetry after we were on the surface?
I don't know if we got telemetry or not, but they certainly got plenty of signals back.
Oh yeah, we got 9 to 10 minutes of two-way Doppler on the surface, so that'll help us get some kind of estimate of where it is.
Never mind the estimate. I think we can claim that we soft landed on the surface, right?
Yeah.
I don't think there's any doubt about that.
We have a velocity estimate for the impact. Do you want that?
Yes.
Okay, it looks like between 1.5 and 1.8 meters per second.
Which is how much in miles per hour?
I knew you'd ask that.
Well, why don't you have the answer for it? Multiply it by 2.24. I don't have the calculator here. 1.5.
3.36 miles per hour.
3.6 is what? Is
3.36 miles per hour impact.
3.36.
Plus or minus a little bit.
Plus or minus what?
Okay, I knew you'd ask that.
1.5 to 1.8 meters per second. That's the number I really want, right?
Right.
Okay. Okay. 3.36 corresponds to what? The 1.5 number?
Yeah.
Okay.
That's the low one.
Okay, that's the low one. Okay. Okay, this is good. We hit under 2 meters per second, though. That's the idea. Yeah.
Yeah, there is some uncertainty with exactly.
Yeah, there's some uncertainty, right. Well, I have to admit that this is, I never really expected to hear from it after we hit.
Yeah, us either, but everybody here was pretty excited.
So, this is the first time that the United States has ever been the first to land on another solar system body. Is that correct?
Go by that.
Okay. That's good. This is good. What do you want? An update, yeah. Let's see what the number is. Okay, no, not there yet. Well, I'm very happy to report that the Near Shoemaker spacecraft is safely on the surface of Eros, and it still is transmitting. It hit at between 1.5 and 1.8 meters per second. So we can say that this is the first time that the United States spacecraft has been the first to soft land on another solar system body. So we're all very happy about this, and we're still celebrating. No, you don't have it.
Okay, hang on. Okay.
Stand by.
Okay, we're going to be wrapping up our live coverage of the near controlled descent to the surface of Eros here very shortly. I just want to state that this was a complete success, that all braking maneuvers were performed as planned, and that it does appear that we had a relatively soft landing to the surface. We will be wrapping up or going over the results of today's activities at a press conference on February 14th at 1 p.m. Using Telstar 5 Transponder 12. And again, participants, many of which you saw here today, will be going over the results from the landing, some of the images that were played back at the very end, and also the performance of the subsystems. And we also hope to give you an update on the health of Near at that time. And with that, I'd just like to conclude what's turned out to be a highly successful day here at the Johns Hopkins Applied Physics Laboratory. And thank you for attending this activity, and I hope you enjoyed yourselves.